So my name is Heelen Kernebeek. I'm working at the Agricultural Economics Research Institute in The Hague, the Netherlands. Today I will give a short presentation because following my presentation there will be another colleague from the Netherlands, Anne Gaasbeek, going a little bit more into one particular protocol that we have developed within the Netherlands. So carbon footprinting protocol for the agri-sector. I will start with a short motive of why are we actually doing this. Then I will explain why the PAS 2050 is used as a baseline for a more specific approach for agriculture. And then I will show you a number of examples of protocols or models that we have developed at Wageningen University and Research Center, of which LAI is a research institute, and partners, and a look into the future. Where do we want to go from here? Well, it has been outlined in previous presentations today that the whole issue of climate change started with an increased awareness. The IPCC has identified climate change as one of the biggest challenges that we face today, and the agricultural sector contributes for 10% to the anthropogenic greenhouse gas emissions. Therefore, it is quite important to have a further look at agriculture. It was acknowledged by the retail and the agri-food sector or the agri-food businesses that sustainability can be used as a differentiation strategy and in particular could be for the topic of greenhouse gas emissions. Therefore, one started to reduce, or to pay attention to reduced transport distances and to avoid air flights using the airplane. But later on one started to realize that it is important to look at the greenhouse gas emissions during the complete life cycle of a product. And then the PAS 2050 was developed to compute or to give a guideline on how to compute the greenhouse gas emissions using exactly this methodology that we call the life cycle assessment. I'm not sure to what extent you are known with the elements of the life cycle assessment, but I'll just briefly mention to you that within the PAS 2050 and within life cycle assessment, it is very important to define your functional unit, which is the unit to which you ascribe the greenhouse gases that are emitted, to define the system boundary in order to make clear which steps in the process you do take into account and which steps you do not take into account, to include all the greenhouse gases besides CO2, also methane, nitrous oxide, and if possible also some other greenhouse gases. And you have to define also your allocation strategy where two products are produced in one and the same step. So the PAS 2050 is a very good baseline which can be used in agriculture. However, because of its non-specificity, agriculture has some additional needs. And to point out what these needs are, I would shortly mention to you the aspect of land use and land use change, which we came across earlier today. Also, the issue of trade-offs. There is a cow on the picture, which is quite what you can expect for a Dutch researcher. But trade-offs are very important, especially in the case of ruminants. You can reduce your greenhouse gas emissions for feed production, for example, but when in the same time methane emissions are increased because of a change in diet of feed composition, your net result may even be negative. Waste treatment and recycling is very important, and also combined heat power. In Dutch horticulture, 75% of the primary producers uses combined heat power. So it is very important to have a good calculation rules on how to compute the greenhouse gas emissions related to this. Well, we have tried to tackle some of these issues, and for now I called it the best practice. Within Wageningen University and Research Center, together with partners, we have developed some protocols and models for different sectors within agriculture. One is the horticultural protocol, which my colleague Anne Gaasbeek will later on get more into detail in. This is a protocol for which we have also developed an online tool for primary producers to compute their own greenhouse gas emissions. Then there is a protocol for animal feed production and for pig and arable production. And for milk production, we have developed also a quite intensive or complicated or a big, let's say, detailed model for computing greenhouse gases related to the production of both conventional and organic milk. So these are some very nice results. These protocols and models, of course, are always open for discussion and improvement. Some topics that we would like to develop further, to go into more detail in the future, is that we would like to add more models and protocols on other sustainability issues, such as the water footprint and biodiversity, in order to get the complete picture of ecological sustainability, besides the problem of climate change. We would also like to contribute to an access and a better quality of databases, getting the databases more country-specific or more region-specific, getting them up to date, etc. And, well, what has been mentioned many times today, I think accreditation guidelines and harmonization is what we all are in favor of. These are my contact details, and now my colleague Anne Gaasbeek will tell you something more in detail about the horticultural protocol, including the tool.